Did you guys all see your grades from the quiz you took last week? So some of the grades were not very good. I do try, like say I give a test and there's only one A or something like that. I do try to, like, maybe I took it out of 100 points, but when I put it in the grade book, I might put it out of 90 points or something like that to help your grades a little bit. But there were some people that didn't really know what was going on parts of the quiz. So, we have 3 new days for this chapter. And then on Thursday and Friday, we have a practice test. And on Thursday, I could like go over the parts of the test that were on the quiz for anyone who wanted me to kind of do like an in-class quiz review. You guys will just have to let me know that if you want to do that. That's what I did when I taught the class in the winter, but it was because we had Christmas break. So that was why I did that, but I can certainly do that again on Thursday. And then I did 2 practice tests and then your test will be on Monday. Okay. Before I get started, I have to tell you guys what happened to me on Friday. So Friday was just a hectic day. I had meetings. I take care of my dad and my sister. I have a disabled sister. She has MS and she's in an assisted living. And so if you ever notice I get phone calls, it's because my dad's not doing well right now. And so I'm the one that gets all the calls. So Thursday, I got a call at school that said my dad has these stroke-like symptoms. So they think he's having a stroke, like his mouth will droop. He'll get really weak on one side. He won't be able to sit up. He'll lean to one side. He can't speak at all. Like, oh, and he couldn't like feed himself, that kind of thing. But then it typically gets better. So I told them, like, this is probably the 8th time that's happened. And I was like, just let it, just kind of watch it. If it doesn't get better by later, give me a call and we'll have to send him to the hospital. Well, I didn't hear anything. And so the next morning I had an appointment at 10 for like a meeting at the nursing home. And I walk into his room and it's 10 a.m. and he's in bed, which would never be the case with my dad. And I was like, oh my God, what's wrong? And he was like so sound asleep, I couldn't wake him up. And I'm like, oh my God. So I go out and I get a nurse, and the nurse comes in and she tells me that he can't speak, that he couldn't feed himself. She had to prop him up in his wheelchair. He was leaning over. Just all these things. And I'm like, okay, we need to call the ambulance. So I hadn't showered yet. I was like, and it was in walk-in. So I'm like, I'm going to run home and shower. I'll meet him and the ambulance at the hospital. So as I'm driving home, my son calls me. So our middle child, don't tell Chase that I told this story. So Chase loves our cat. We have this cat. He calls him her chicken. Her real name is Lexi, but Chase loves this cat like you would not believe. And we had Stanley Steamer. Do you know what Stanley Steamer is? They like shampoo your carpets and stuff. We had them come on Friday. And when they come, they don't shut your front door all the way. So he finds out his cat is missing. And he is so mad at us because we had Stanley Steamer come and now his cat is gone. So I get home and I'm frustrated with my husband because I have to get to the hospital. My husband's sitting there and I'm like, get some boots on and go outside and find the damn cat. Like, what are you doing? So I put on boots. I go outside and I'm looking for this damn cat under every tree, every bush, and then the worst part is I'm calling chicken, so I'm saying, chicken, chicken. So if this old guy that I don't even know, he lives like 2 or 3 houses down, comes out on his deck to like find out what the heck I'm doing out there. I'm like, oh, we just lost our cat. Its name is Chicken, so sorry, explaining myself. Well, I don't find the cat. So then I go, I shower, I decide I'm leaving it to my husband. So I get out of the shower and my husband's still sitting there and I'm like, Colin, get some boots on and go find the damn cat, So he does, and I mean, everything about my husband is just, oh, nothing rushed at all. So all of a sudden, I get ready, I come to the top of the stairs, and he's sitting at the chair like this, he's got his elbows on his knee. I'm like, what's wrong? He went outside and he fell on the ice and hit his head, his elbow, broke his toe somehow on our front concrete steps. And my husband's a baby, so I'm like, oh my gosh, now he's hurt. I didn't even really like pay much attention to him. I was more worried about the cat, to be honest. And I was like, okay, so I'm gonna go to the hospital. I hope you're not concussed, but please help Chase find the cat. So I leave. And as I leave, I call my other son, Tyler, he's married and lives on the Rich Spring Golf Course. I'm like, is there any way you and his wife could come over and help look for the cat? Grandpa's taken to the hospital. I need to go there. And they tell me that their cat has eaten something and has a bowel obstruction and needs to go to the cities because it has a heart murmur and they have to pay $5,000 for this cat to get surgery. And, most people would probably just put the cat down, but we are like weird animal family. Like we love our animals so much. So Tyler literally takes the cat to the city. They're gonna pay $5,000 to get it fixed. So I go to the hospital and I'm there all day. In the meantime, Chase goes and walks in his room and there's his cat. The whole time the cat was we have a 4th level that is just storage. And I think she got scared and she went downstairs and she was in our house the whole time. Then, what else? So my dad is doing okay. He's still in the hospital. They don't know what's going on. So that's okay. My husband, he did break his toe. His toe looks terrible. And he, of course, got hurt. But then, okay, so I thought 3 things, that's good. So Saturday morning, I go into the hospital and my dad is just totally freaked out about where he's at, why he's there, couldn't remember anything. So I grabbed this wheelie chair, like it's not a wheelchair, but it was a chair with wheels. And I pull it up next to his bed to like calm him down. And I sit in the chair and the chair flips all the way back and I just fall so hard onto the ground right on my butt. Well, the chair flips up and the wheel or one of the legs of the chair flies through a cabinet and breaks the cabinet. And my dad screams when I fall because he was so scared that I got hurt. So he screams. So all of a sudden, all these people run into the room and I'm sitting on my ass on it. And they're like, are you okay? Are you okay? I'm like, yes, I'm really okay, but your cabinet's not, and I tried to get that fixed. And so, yeah, that was my weekend. Isn't that terrible? Oh, and here's the best part of my son's cat that went to the cities. They had to go to an ER vet. And when the place here said that it had a bowel obstruction, when they went there, it was food in the cat's stomach that the vet saw. And they still had to pay $2,200 and nothing was wrong. So, yeah. They had to pay it, not me, so that's good, but I'm like, oh my gosh. So yeah, not the best weekend. All right. So on Thursday, we graphed square root functions. Today, we're gonna graph cube root functions. So on Thursday, we had things that had a square root. Today, we're gonna have things that have a cube root, and I'd have to give you. I need to give you the books, yeah, right? So I made up a cheat sheet for today. And I'll explain it once I hand it out. All right. So on this cheat sheet that I gave you, the front side of it is what I should have given to you on Thursday. That was when we tried to get the numbers 0, 1, 4, and 9 under the square root. Today is the back side of this cheat sheet, and we're doing cubed roots. So what we want to get under our cubed roots is -8, -1, 0, 1, and 8. And that is because when you take the cube root of those three numbers, it gives you a whole number, okay? So I'll talk about that in a second. So when you have a cubed root, it's either going to look like this, okay? Or it's going to look like this. One of those two. And one of the things that's going to ask you for today is called an inflection point. And it's easy to tell by how we graph what that inflection point is. But like in this blue one, it would be this point right here. It's kind of like where it stops going up and kind of changes direction a little bit. Okay, so they're going to have an inflection point. The other thing that we're going to have to say today is like, as your x approaches infinity, what does your graph approach? And we did this back in first trimester. Like as your x gets bigger and bigger for the blue graph, do you guys notice that this is just going to get bigger and bigger? And so it's going to approach positive infinity. And this blue, it would, if we did as x approaches negative infinity, which is right here, x approaches, it's going to get smaller and smaller and smaller. So it's going to approach negative infinity. Okay. So the first type of question, all it does, it gives you a function, it graphs it, and it asks you what happens as your f of x approaches negative infinity, or I'm sorry, what happens as your x approaches positive infinity, and what happens as your x approaches negative infinity. So this graph, this is infinity. As x gets bigger and bigger, notice our graph gets smaller and smaller. So our f of x would approach negative infinity because it's getting smaller and smaller. As it goes this way, as x approaches negative infinity, as it gets smaller and smaller, this graph is just going to keep going in the positive direction. So what's going to happen is your f of x, which is your graph, is going to approach positive infinity. Okay. So if I look at this one, this is what, oh, and the other thing they want us to say too is what is the domain and what is the range? The domain is what X is your graph covered by. And always today, your graph is going to go through the whole graph on the X's, as well as for the Y's, it's going to go through all of the Y's. So because of that, for every one today, our domain and range are all real numbers. Okay. You guys could even on your cheat sheet for the test, on the side for the cube, you could write on there, domain is always are all real numbers and range is always all real numbers. Okay. This is a cheat sheet and these are things. All right. Now it asks us as X approaches infinity, which is this way, what do you think our graph is going to approach? Is this going towards positive infinity or negative infinity? If it's going down, it approaches negative infinity. As it approaches negative infinity this way, notice our graph is getting bigger and bigger and bigger. So this would be positive infinity. And then the last thing that it does is ask for that inflection point. And it would be like these graphs always have this area where it almost like flattens out. And it would be the center of that. So kind of like the midpoint of this would be where that inflection point is. And you just write the coordinates of that point. If this is my origin, that point would be -1, 2, 3, and then it's not any up or down. So it'd be -3, 0. Then if I look at this one, if you look at what's happening as my X is approaching infinity, this is getting bigger and bigger and bigger. So as X approaches infinity, our graph is approaching positive infinity. As my X approaches negative infinity, this eventually is going to just keep going and going into the negative part. So this is going to be negative infinity. The domain and range are always all reals. And then the inflection point, notice it flattens out right here. So it's that point right there. Here's my origin. It's over 1 up 2. So it's the 0.12. So that's when they give us the graph. This is on your cheat sheet. And last week, like I said, we tried to get the points 0, 1, 4, and 9. And then we took the square root of that. And somebody asked me, like, why do we use 0, 1, 4, and 9 versus -1, 0, and 1? And that's a good question. You want -1 doesn't have a square root, so you can't use that. You'd have to have positive numbers. But you also, the reason we're doing that is so we don't have to have decimal points. When you take the square root of 0, square root of 4, square root of 9, they're all whole numbers. So that's why we do that. Now with a cubed root, you can have negatives. You can take the cubed root of a negative. You can't a square root, but you can a cubed root. So what you're trying to get here is you want this to be -8, -1, 0, 1, and 8. And then down here, I wrote what the cubed root of -8 is. It's -2. The cubed root of -1 is -1. The cubed root of 0 is 0. Cubed root of 1 is 1. And the cubed root of 8 is 2. Okay. So now they are going to ask us to graph a function. And I already put these off to the side, but I don't think they're on yours. But these are the numbers we want to get under here, okay? Or I shouldn't say that. They're the numbers we want to get under the cubed root. If this is just an x, it's much easier because then that is the numbers you put in there. A lot easier when it's just an x. And then what you can do, and I also have this up here, looks a little bit different than on the cheat sheet, but the cubed root of -8 is a -2. And then you would have 4 times a -2, which is -8. Okay. Then you're going to put the -1 in here. The cubed root of a -1 is -1. And you have to multiply that by 4. 4 times a -1 is -4. Okay. Then if I put a 0 in there, the cubed root of 0 is 0. 0 times 4, 0 times anything is 0. And then if I put 1 in here, the cubed root of 1 is 1. 1 times 4 is 4. And then when I put 8 in there, the cubed root of 8 is 2. 2 times 4 is 8. So we're going to go over to our graph and we're going to graph that. So at -8, we're going to go down to -8. At -1, we're going to go down to -4. At 0, we're at 0. At 1, we're at 1, 2, 3, 4. And at 8, we're at 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's what our graph is going to look like then. Is like that, and they always should do that today. Sometimes they'll come down and then turn. Others, they'll go up and then turn, okay? When you do this, remember again, your domain and your range are all reals. You look at your graph and you say, what happens as x approaches infinity? Notice my graph is getting bigger and bigger, so that's positive infinity. And as my graph approaches negative infinity, it's getting smaller, so that's negative infinity. And then your inflection point, if you graph it the way I do, is always going to be that middle point, okay? Which is 0, 0. And you can also see that on the graph that that is your inflection. Okay. So then if we go here, this one's going to be a little bit harder. And the reason it's harder is because it has x plus 1 there. Now I just added these numbers over to the side this morning. So you might want to just copy those down on the side. Okay. And this is where you have to think, what would I put in here that when I add 1 to it, it's going to give me a -8. And if that's hard for you, especially when it's negative like that, that's hard for you. You might want to just take this x plus 1 and set it equal to -8 and solve it. Here you'd subtract 1, and that would be x equals -9. Okay, then if you, for the -1, you could say, what happens if x plus 1 has to equal -1? You would subtract 1, and x would be a -2. Okay, So let's go ahead and do those. -9 plus 1 is a -8, and it should be, okay? And if I go back up here, the cubed root of a -8 is -2. So this gives me a -2, and I have to multiply that by a -2. -2 times -2 is a +4. Okay. Then we found out we were going to put a -2 in here. Okay. -2 plus 1 is a -1. The cubed root of a -1 is -1. -1 times a -2 is a +2. Then I need to get a 0 under there. That one might be a little bit easier to do in your head, like what plus 1 would give us a 0? That's -1, but if not, just do x plus 1 equals 0 and solve that, okay? -1 plus 1 is 0. The cubed root of 0 up above is 0. So this much is 0 times a -2 is 0. Then if I put 1 in, or I have to get 1 in there, so I think what plus 1 gives me 1? 0. 0 plus 1 is 1. The cubed root of 1 is 1. 1 times a -2 is -2. Then I think what would need to be underneath there, that if I add 1, it's going to give me 8. It'd be 7. 7 plus 1 is 8. Okay, so this is going to be 7. 7 plus 1 is 8. The cubed root of 8 is 2. 2 times a -2 is -4. Okay, and then I have to plot those points. So -9 is up 4. -2 is up 2. -1 is 0. 0 is -2. And then 1, 2, 3, 4, 5, 6, 7 is down -4. 1, 2, 3, 4. And then you could draw that graph. Make sure the graph covers your whole graph, like it comes off the graph on both sides. And then we're ready to go down and fill in the characteristics of the graph. So domain and range are always all reals. And then as x approaches positive infinity, notice this is going in the negative direction, so negative infinity. As x approaches negative infinity, it's going in the positive, so positive infinity. And the inflection point is at -1, 0, which is the middle point on our graph. Or where it kind of switches. Questions on that? One more, and then I'll let you guys get started. So the more they add to the graph, like here, we have to figure out something here. Then we have to multiply it by 3, and then we have to add 2. So that gets a little bit more challenging, but we do it the same way. We're trying to get -8, -1, 0, 1, and 8 under here. And again, if that's hard, do x minus 1 needs to equal -8. And how could I do that? I'd add 1. So x would equal -7. -7 minus 1 is a, yep, Abby, please. Yes. -7 minus 1 is a -2. But then you have to take that -2 and times it by 3. 3 times a -2 is -6. Then you have to take that -6 and add 2. And those things you could do on your calculator if you needed. You could go what's this? -2 times 3 plus 2, you could punch into your calculator, but that's gonna be -4, okay? Then I have to get a -1 under there. So again, if that's hard for you to do in your head, just set up this equation where you set x minus 1 equal to -1, and it's 0. Okay. 0 minus 1 is a -1. The cubed root of a -1 is -1. So this part right here is a -1. -1 times 3 is a -3. And then you have to add 2 to that, and -3 plus 2 is -1. And that part, if you need to go -1 times 3 plus 2, you can certainly do that. Then we have x minus 1, and we want it to equal 0. So you could add 1, and x would have to equal 1. Okay? 1 minus 1 is 0. The cubed root of 0 is 0. 0 times 3 is 0. 0 plus 2 is 2. So this was what? 0, 8? Yeah, or 1. It's 1. 1 minus 1 is 0. 0 times this is 0. 0 plus 2 is 2. Okay. Then I'm gonna say, well, what happens if x minus 1 has to equal 1? That becomes easier to do in your head when it's positive, but 1 plus 1 is 2. And that is because 2 minus 1 is 1. The cubed root of 1 is 1. So this is 1. 1 times 3 is 3. 3 plus 2 is 5. Okay, and then that last one, this one's probably easier to do in your head too, but we want x minus 1 to be 8. So if we added 1, we'd need x to be 9. Okay. So 9 minus 1 is 8. The cubed root of 8 is 2. This whole thing is 2 times 3 is 6. 6 plus 2 is 8. So now I'm going to go ahead and graph that. So at -7, I go down to -4. At 0, I'm down at -1. At 1, I'm up to a +2. At 2, I'm up to a +5. And then way over at 9, I'm up to 8. Yeah, and then if we graph that, it looks like that. And then we're able to do the domain, the range, and so on. Domain and range, always with cubed roots, is all reals. As x approaches positive infinity, this approaches positive infinity. As x approaches negative infinity, this approaches negative infinity. And the inflection point, you can cheat and take that middle one, is 1, 2, which on your graph is that point. Is it hard today? I'll get you guys the worksheet. And you're gonna like absent on there, so I don't take points out. And remember, if you didn't take the quiz, set up a time with me this week so you can get that taken.
Your next one of these.
Yeah, is that what I just handed
Yeah,
out?
you're just one for.
Okay, sorry. Right there.